Welcome everyone. My name is Jayme Holmes. I'm the lead programmer for DrugCentral. My background's in computer science, software engineering, UI and UX. I've been at the University of New Mexico for over 14 years and part of the IDG HSC Health Science Project. So DrugCentral, it's a drug resource that the user can search veterinary drugs, adverse events, indications and contraindications of drugs. They can enter a drug target, a UniProt ID, and they also can search by structure and do a similarity search on smiles. So on our download section here on DrugCentral as well, you can download the SQL Postgres database. We have public and published versions of DrugCentral at nucleic acid research in 2017, 19, 21, and 23. So let's go ahead and give you an overview as how DrugCentral has grown over the time. So in 2017, we had drug approvals, external references, indications and contraindications. We had target annotations and target classifications. For our drug products, we were accruing drug labels, marketing status, and route. Then in 2019, we incorporated FAERS adverse event reporting system data, including L1000 genes and target development levels, which Jeremy mentioned earlier, and FDA Orange Book data. In 2021, we added drug repurposing categories. We added sex-based separation of FAERS and Redial 2020, an application utilizing machine learning for COVID-19. Then in 2023, we added veterinarian drugs, off-label usage as well. So this is a new feature we want to incorporate into DrugCentral 2025. And I'll go ahead and boot up this avatar.
Will help guide us through this presentation. We have several important topics to cover for DrugCentral. I will be discussing drug types, bioactivity data, data integration. We'll examine adverse drug events, status trends, and observations. Let's get started. Let's take a closer look at the data curation and integration process we use to compile the DrugCentral database. The process involves several steps to ensure accurate and up-to-date information. Punctual updates and data preparation, steps 1 through 3. We update tables, data sources, molecular properties, and drug repositioning categories to keep our database current. External identifiers, step 4. We integrate various identifiers such as MESH, PubChem, CID, IUPACHR, DrugBank, UNIA, and more to ensure comprehensive data coverage. Pharmacological classes, step 5. We use sources like Dalind RX, Dalind OTC, and Orange Book to classify drugs pharmacologically. Drug products, step 6. Information from Dalind RX, Dalind OTC, and Orange Book is used to update drug product data. FAERS data, step 7. We incorporate OpenFDA data and compute LLR descriptors for male, female, and neutral populations to monitor adverse events. Bioactivity data, step 8. We update targets and activities using data from IUPACHR and Chembl to provide detailed bioactivity information. ATC code and files, step 9. Finally, we map drugs to ATC codes, provide summaries, download files, and exchange files for TCRD. This comprehensive approach ensures that our data is accurate, up-to-date, and highly useful for various applications. In this slide, I'll talk about the latest updates of the main features and functionalities. I'll start with drug types. The current DrugCentral version, available online, comprises 4,995 drugs. The vast majority are small organic molecules, roughly 85% of the entries, while overall the other categories account for 15%. The same trend is followed by the orphan drugs, representing roughly 9% of the drugs in DC. Regarding the number of newly approved drugs, 2023 has been monitored up to August. For the previous years, steady trend in 2019, 2021, and 2023 can be observed, with a slightly larger number of drugs indexed in 2020. This slide presents a summary of bioactivity data in DrugCentral from various sources, showcasing the number of activity points, drugs, and targets. The total activity points amount to 20,978, covering 2,754 drugs and 3,205 targets. The data sources include ChemLab, WOMBATPK, Drug Matrix, IUPHAR, Scientific Literature, PDSP, and drug labels, with mechanisms of action data provided in parentheses. In our DrugCentral database, we have 3,205 drug targets, 733 MOA targets, 606 of which are of human origin, 1,933 drugs. The chart below shows the distribution of drug targets and drugs across various classes, including enzymes, kinases, GPCRs, ion channels, transporters, and others. Regarding target development levels, TDL, we have annotated 1,635 targets. T-Clin, 564. T-Chem, 738. T-Bio, 312. T-Dark, 21. This classification helps us understand the maturity and knowledge depth of each target, guiding research and development efforts. In this slide, I'll briefly explain the target development levels, TDL, for drug targets in DrugCentral. 1. T-Clin. These targets have activities in DrugCentral with known mechanisms of action and are associated with approved drugs. To T-Chem, these targets have activities in Chembl or DrugCentral that meet specific activity thresholds. Some targets are manually curated based on small molecule activities from various sources. 3. T-Bio. These targets lack known drug or small molecule activities that meet activity thresholds. However, they satisfy one or more of the following. 1. Meet criteria above the T-Dark cutoff. 2. Have gene ontology annotations with experimental evidence. 3. Have confirmed OMIM phenotypes. 4. T-Dark. These targets are poorly understood with minimal known activities. They meet 2 or more of the following criteria. 1. A PubMed text mining score from Jensen Lab. 2.3. Gene RIFs. 3.50 antibodies available according to Antibodypedia. This classification helps in understanding the different levels of knowledge and research available for various drug targets. Now let's review some DrugCentral data. Trend overview. The line graph illustrates the yearly number of first-time drug approvals from 2017 to 2021. There is a clear upward trend, indicating an increase in the number of new drug approvals. Key data points. The number of approved drugs is generally increased each year, with a noticeable peak around 2020. The dotted line represents the 10-year moving average, which also shows a consistent upward trend, confirming the growth in drug approvals over a longer period. This positive trend reflects advancements in drug development and regulatory efficiency, suggesting a robust pipeline for new therapies and treatments. This upward trend in drug approvals is a promising indicator for future innovations in healthcare. Now let's discuss DrugCentral adverse drug events data. The dataset in DrugCentral includes significant adverse events that have been reported, providing a valuable resource for identifying patterns and potential risks associated with different drugs. The categorization by sex and age allows for more targeted analysis and better understanding of how adverse events may differ across these groups. Indications: 1,045s, with 258 unique indications. Species covered: 34. Products: 1,492. Chemical structures: 328. Synonyms: extensive list to ensure comprehensive coverage. Venn diagram insight illustrates the overlap and distinction between veterinary, 154 unique, and human drugs, 4,531 unique, with 242 drugs common to both categories. Significance: first open access resource for veterinary medicines, enhancing accessibility and utility for veterinary professionals. We look forward to further enhancing our database to support both human and veterinary healthcare needs. In this slide, the chart highlights the significant presence of human drugs across all categories, but also showcases the essential role of veterinary drugs, particularly in the prescription (RX) segment. Understanding these distributions is vital for optimizing drug development and ensuring that both human and veterinary healthcare needs are adequately met. This slide lists the key publications related to DrugCentral, highlighting significant advancements and research contributions in the field of drug discovery and repurposing. These works, published between 2019 and 2023, cover topics such as novel drug targets, off-label drug usage, and the integration of human and veterinary drugs, underscoring DrugCentral's pivotal role in supporting clinical and molecular drug research. The DrugCentral website also has 85,000 users annually according to our Google Analytics GA4 data and continues to grow. As we look ahead to 2025 for DrugCentral, there are several key areas of focus. Drugs in the latest scientific papers. We will integrate the most recent finding from scientific research to keep our database up to date. Drugs in open clinical trials. We will include information on drugs currently being tested in clinical trials to provide a comprehensive view of ongoing research. Redo disease components. We plan to reevaluate and update the disease components to ensure accuracy and relevance. Update LINCS gene chemical. We'll be updating the LINCS dataset to include the latest gene and chemical interactions. Proteomic drug target interactions. We aim to enhance our database with proteomic data on drug target interactions, leveraging resources like DeepCoverMoa. Add formulations from EMA. Finally, we will incorporate drug formulations from the European Medicines Agency to expand our international coverage. And I will be added to the DrugCentral UI to assist users to run advanced queries on the DrugCentral database to help with drug discovery. Yes, that is right. I will help run advanced queries on the DrugCentral database to help with drug discovery and use my AI capabilities to help all DrugCentral users. These initiatives will ensure that DrugCentral remains a leading resource for drug information. Jayme and I can answer any questions at the end of this webinar. Thank you once again, Jayme Holmes, for allowing me to assist with the DrugCentral presentation and for programming my avatar, which you have named Ian. I look forward to collaborating with all of you in the future. Ian, signing off for now.
Well, thank you for that. That's just a prototype of what we want to implement on the next version of DrugCentral.